Hello, this is Lazarus at telecomTech, where telecom and networking technologies are simply explained. Today we'll be simply explaining Inter-VLAN routing. When implementing VLANs, we logically separate a switch into multiple layer 2 domains, where groups of ports belong to a particular VLAN. Direct layer 2 communication cannot take place between devices in different VLANs. Not only are these logically segmented broadcast domains, but the hosts within them typically belong to different subnets. Remember, VLANs typically align with the IP addressing that is assigned to hosts in each subnet. So in order for these hosts to communicate, we need to introduce a router. That router will act as the default gateway for each of these subnets. It will route traffic and then send it to the other subnet. So typically, we'd need something like this. A router with an interface connected to multiple ports on the switch, one in each VLAN for which we want it to act as a gateway. Communication from host A to host B would send traffic to the default gateway, the packet would be routed, and it would be sent to the corresponding other subnet through this port here to reach the intended host. Now this seems a bit cumbersome. What if you have 3, 4, or 5 VLANs here? You would need 5 additional ports to connect to an external router. What if you have 20 VLANs? Immediately, you can see that this does not scale well. So there must be a better way to do this. Now, one way is to use what is known as a router on a stick. That's when you create a trunk between the router and the switch. And the router has multiple sub-interfaces on this physical interface here, allowing each VLAN access to a default gateway via this one single link. Now, we'll talk a little bit more about trunks in a future video, but concerning this setup here of the router on a stick, I won't go into the details of how this is configured at this point. But this too has some drawbacks. You have a single link carrying traffic from multiple VLANs, making the potential for oversubscription and congestion a real issue. It's also a single point of failure that can potentially cause reliability problems. The ideal solution to this scenario is the use of Inter-VLAN routing. Now, before I describe this feature further, this term needs a bit of explanation. In essence, all routing is inter-VLAN routing. You route from one VLAN to another. Stated more explicitly, you route from one subnet to another, and subnets typically align with VLANs. But the term inter-VLAN routing refers specifically to the routing between VLANs that is performed internally on the switch itself. So inter-VLAN routing is a mechanism made available on switches that allows for routing between VLANs internally to the switch. This means that the switch essentially has an internal virtual router that is able to perform the same routing logic within a single device. So the switch here takes care of the VLANs, but also acts as the default gateway for those VLANs, providing the routing logic and processes internally. So that means that a switch must have an internal interface assigned the IP address that will be used as the default gateway by the hosts in each VLAN. This virtual interface is known as a switched virtual interface, or SVI. This is also known as a VLAN interface in the context of Cisco, as well as other vendors. We create this interface and assign it an IP address within the appropriate subnet. That VLAN interface acts just like the rooted interface of a router. It becomes part of the routing table and is the exit interface for any IP address that will fall within the subnet corresponding to that interface. So for this setup here, if we configure the IP addresses of VLANs 10, 20, and 30, and we configure those interfaces like so, we would see a routing table that looks something like this. So any communication between this host here and this one here can take place via inter-VLAN routing based on this routing table and the routing logic that exists within this switch. Now, keep in mind that all switches are not able to perform inter-VLAN routing. Switches that strictly operate at layer 2 are not capable of this feature. Switches that can perform inter-VLAN routing are typically known as layer 3 switches or multi-layer switches. They must have layer 3 capabilities in order to perform this function. Now, in the realm of Cisco, this capability depends both upon the platform as well as the operating system being used. The device must have the appropriate hardware to do it, and it must also have the capability enabled in the operating system. It's similar for other vendors as well. Now, the benefits of Inter-VLAN routing are multifold. First of all, you have only a single device performing switching and routing. You don't need to waste any ports to connect external routers. The configuration is much simpler and more elegant, and you're not limited by the bandwidth of a single link for communication with the routing device, since communication for routing takes place within the switch itself via the backplane, which typically has very high throughput. The switch can also act as a routing device not only for the VLANs that it has configured, but also for any other subnets that you may have on your network that are external to the switch. There are, however, some limitations. Layer 3 switches perform routing just fine, but they are generally less feature-rich than routers. They are more limited when it comes to features such as advanced WAN technologies, deep traffic manipulation, or specialized routing services. For general routing, Layer 3 switches are fine, but if you need to perform things like WAN encapsulation, advanced QoS, VPN services, or MPLS, it's best that you use a pure router for these. So that's it for Inter-VLAN routing. For now, if you're still here, I just want to thank you, because sticking around to the end tells me that you're serious about actually understanding how networking works, and I genuinely appreciate that. If you're looking to take things further, I recently launched my website at www.telecomtech.io, and that's where I'm building structured courses with hands-on labs, quizzes, and real-world scenarios. It's still in the early days, but there's more coming soon. Feel free to check it out. Join the newsletter so you'll be the first to know about new content along with some exclusive offers that I may give along the way. I'm Lazarus at telecomTech. I hope this has been helpful for you, and I'd like to thank you for watching.